Hi all, this is just an announcement that as of ArcGIS Pro 3.5 there was a spatial clause parameter added to the definition queries, and I've added the videos to the end of this section. As you were going through the initial videos, if you were following along, you were going to see the spatial clause property in your definition queries, whereas they won't be in the initial videos. They'll be at the end, where I've added in information on the spatial clause after the initial course was made. All the best with your learning. Take care. In this video, we will add a definition query to a layer using the definition query property available with an ArcPy layer object. We are in the ArcPy definition query APRX and in the definition query map. The only layer that we have visible is the county boundaries that we can see in our map window. Click into the Analysis tab. On the left hand side where it says Python, click the drop down and select Python window. It might take a moment or two for the Python interpreter to initialize. We first need to use ArcPy to provide a gateway to our APRX. We'll create a variable called APRX and use the ArcPy MP module and the ArcGIS project class to create an ArcGIS project object. We supply in the string current to access the open APRX and we hit enter. Just to show that we now have access to our APRX, we'll go APRX dot active map dot name, and we can see our active map is our definition query map. We'll create a map object called M, and we will use our APRX.listMaps function, and we will supply in our def query map as the wildcard, and we only want the first map object returned. Now if we go m.name, we get our def query map again. So our M variable is a map object representing our def query map. From our map, we want to access our county boundaries layer. We will create a variable called layer, and we'll use our map object list layers function, and we'll supply in our county boundaries name as the wildcard. And we're only interested in the first layer returned that matches county boundaries. We'll hit enter and we can check if we got the right layer with layer.name, and we have county boundaries. The layer object has a property called definitionQuery. We go layer.definitionQuery and hit enter. We can see we have returned an empty string. This indicates that there is no active definition query for our layer. If we go up to the contents and right click on county boundaries and go to properties and the definition query on the left hand side, we can see that there are no definition queries defined. Click cancel. We'll go back down to the Python window. Let's set a definition query. We'll set layer.definitionQuery equals, and the definition query will be a string. We will use double quotes. We're going to use the county attribute from the county boundaries layer, and we want where the county equals Mead. Now the attribute value needs to be surrounded in single quotes, so I will add those around Mead. Before hitting enter, I'm just going to open up the county boundaries attribute table to show you we have 4 records. We have our county field and Mead as our attribute. I'll close the attribute table. And if we take a look in the map, we're expecting that County Mead will be the only county showing after we set the definition query. We'll go back down to our Python window and hit enter. And we can see we are left with Mead with the other 3 counties hidden. If we right click into county boundaries and go to properties, we can see our definition query was given a name of query 1, and we can see the definition query that was applied, and this check mark here says that this is the active definition query. Click OK. Go back to the Python window. You can press up and it'll automatically populate with the previous statement. And we'll change Mead to Kildare and click enter. Now we can see we only have Kildare. Let's do one more. We will put in Dublin. And we can see we only have Dublin. Now if we go back into the county boundary properties and into definition query, we can see we have 3 queries. We have query 1, query 2 and query 3. And we can see that query 3 is the active query. Click OK. In our Python window, we'll click up, and this time we'll say county in, and we'll wrap Dublin in parentheses, and after Dublin we'll put in a comma. We will then wrap Wicklow in single quotes, and we will click enter, and we can see we have Dublin and Wicklow. We have now set 4 definition queries using the definition query property for a layer object. If we print the layer object definition query to screen, we can see the active definition query is county in Dublin and Wicklow. In this video, we used the layer object definition query property to add a definition query to the layer. Each time we added a definition query, it became the active query. We have kept the SQL quite simple in this video, but you can add more complex SQL statements to define your definition query. In the next video, we're going to look at listing all definition queries for a layer. In the previous video, we applied 4 definition queries to our county boundaries layer. In this video, we will show how we can list all the definition queries available for a layer. We are in the ArcPy definition query APRX and continuing from the previous video. On the right hand side in contents, if we right click on county boundaries and go to properties, and we're in the definition query tab, we can see the 4 definition queries that we added. Click cancel, and in the Python window we can see the code from the previous video. If you are coming at this fresh, I will right click and clear transcript, and then where we enter the code down the bottom, I will right click and select load code. In our folders, go to ArcPy_DQ, click in and go into Python scripts and select the list definition queries _start.py script and click OK. This is loaded into our code window, and if we click enter and enter again, we are now at the same location we were at the end of the previous video. And if I right click into county boundaries, select properties, we can see that our 4 definition queries are there. When you add a definition query that already exists, it does not add a new one. Click OK. We want to list all 4 of our definition queries. We will use the layer object list definition queries function. We can see here that this function takes an optional wildcard. We will not use the wildcard for this instance. We will click enter, and we can see that we have a list of definition queries. And more importantly, we can see that there's a list of dictionaries describing each individual definition query. Each dictionary has the name of the query, the SQL for the query, and whether the query is active or not. So it is important to note that the list definition queries returns a list, and is a list of dictionaries. We can assign the list definition queries to a variable. We'll call this dq_list. Set that equal to layer.list definition queries, and we'll click enter, and we can use a for loop for definition query in definition query list. Let's print each definition query, and that might be a little bit more readable. We could also return just the names of our queries, so we'll press up, and for the print DQ we will print DQ name and hit enter, and enter. And there we only have the names. We could use list comprehension just to return a list of the names. Let's go with data query name list equals, and we'll set our square brackets. And we'll go with definition query. And we want to access the name value. We'll say name. I need to add back in one of those square brackets for definition query in layer.list definition queries. And we'll hit enter. Now let's print our definition query name list to screen. And we can see we have a list of the names of our definition queries. We can of course use the wildcard. So we'll go layer.list definition queries and we'll supply in an asterisk and a 1, which means that this will return any definition query whose name ends in 1. Hit enter. And we can see we got our query 1, which was county equals Mead, and it is not the active definition query. Because list definition queries returns a list, you can also use indexing to access a definition query if you know where it sits in the list. If we wanted to access our query 2, we could use list definition queries. We'll take out the wildcard and we'll use an index of 1. And we can see we are returned query 2. In this video, we saw how we can use the list definition queries function to return a list of definition queries available for a layer. We saw that the list returned is a list of dictionaries and that each dictionary has 3 key value pairs, one for name, SQL, and is active. In the next video, we will look at turning off all definition queries for a layer, so that we are left with the original layer content. We currently have 4 definition queries available for our county boundaries layer, with the 4th of those queries being the active definition query. In this video, we will show how we can turn off all definition queries so that the layer displays the original content. We are in the ArcPy definition query APRX. Over on the right hand side, if we right click on county boundaries and go to properties and into definition query tab, we can see we have the 4 definition queries that we have set. Click OK. If you're coming here from the previous video, we still have the code here. But if you're starting fresh, I will right click and clear transcript, and down the bottom input ribbon where we input the code, I'll right click and select load code. And we're into folders and into ArcPy _DQ and into Python scripts and select turn off definition queries _start.py and select OK. This will have loaded the code for us. Click enter and enter again. And we are now set to complete the walkthrough for this video. Let's start by printing the active definition query to screen. The layer object definition query property. We'll hit enter and we can see that county in Dublin Wicklow is the active definition query. And if we go into our county boundaries properties, we can see that this is the one highlighted with the check mark. Click OK. Back down to our Python window. We'll create a variable called definition query _lists and we'll set this to be our layer objects list definition queries. We saw in the previous video that the list definition queries returns a list of definition queries as dictionaries. Click enter and we'll print the definition query list to screen. And we can see that our query 4, county in Dublin Wicklow, is the active definition query because the is active key has a value of true while the rest have false. We'll create a for loop for definition query in our definition query list. We are going to set the is active property, the is active key, to equal false for each of our definition queries. Hit enter and hit enter again And if we reprint our definition query list to screen, we can see that they are all false. Now you also might have noticed that it did not update the map. And if I open the county boundaries properties, we can see we still have an active query. We'll click OK. We need to use the layer.updateDefinitionQueries function, and we need to supply in our definition query list as the updated definition queries. As soon as we hit enter here, you will see the map change back to the original content. We'll hit enter. If we check layer.definitionQuery property, we'll hit enter, we can see there is none defined. And if we go back into our county boundaries properties, we can see that there is no active definition query. We'll click OK. In the last video, I mentioned that when you add a definition query that already exists, it does not create a new one. I'm going to copy this county in Dublin Wicklow SQL statement, and I'm going to set the definition query to be that and hit enter. We can see we have Dublin and Wicklow in our map, and if I open the properties and its definition query, we can see that query 4 is once again the active definition query. It did not create a query 5 because the SQL already existed. I'll click OK. And now here's a little shortcut how to clear the definition queries. All we need to do is use the layer object definition query property, and we will set that to be an empty string and hit enter. And we can see this has done the exact same as setting all the isActive values to false. If we open up the county boundaries properties, we can see that there is no active definition query. In this video, we saw two ways to remove all definition queries from a layer. We did not delete the definition queries, we just made them inactive. The first method of clearing was to create a list from the list definition queries function. We then updated the isActive property for each dictionary returned in the list, and we then used the layer object updateDefinitionQueries function to turn off all definition queries for the layer. We then saw that there was a simpler way to do this by just supplying an empty string to the layer definition property. In the next video, we will add a definition query to our layer using the updateDefinitionQueries function. In this video, we are going to add a definition query to a layer using the updateDefinitionQueries function for a layer object. We are in our ArcPy definition queries APRX. In the previous video, we cleared all definition queries from our county boundaries layer. This does not mean that we deleted them, we simply made every definition query inactive. Over on the left hand side, if we right click on county boundaries and select properties, we can see we have 4 queries but none are active. We'll click OK. If you are here from the previous video, we will be continuing from where we left off. And if you're starting here from fresh, we can right click and I'll clear the transcript, and down where we type the code in the input ribbon down here, I'll right click and select load code. We'll go into folders and into ArcPy_DQ and into Python script and select add update definition queries _start.py and select OK. This will load the code that'll get us up to speed for this video. Hit enter and enter again. We've seen that we can access the list of current definition queries when we use the list definition queries function for a layer object. And we know that this list is made up of a list of dictionaries, and we also know that each dictionary has 3 key value pairs: name, SQL, and isActive. We will use this dictionary structure to add a new definition query. We'll create a variable called DQ and we'll set this to be a dictionary object. We'll set the name key with a value of Wicklow. We'll set an SQL key with a value of county equals Wicklow, and we need to wrap Wicklow in single quotes because it is a text attribute. If it was a numerical attribute, we would omit the single quotes, and we'll set the isActive key to be true. So when we do update our definition queries, this will be the active definition query. Hit enter. We'll now create a variable called dq_list, and we will set this to be our layer objects list definition queries. So the return from the list definition queries function will be applied to our dq list. We'll click enter and we'll print the dq list to screen, and we can see our 4 current definition queries, and then none of them are active. They all have an isActive property of false. We will now append our new definition query to this list. So we'll call dq_list.append, which is the Python append method for a list object, and we'll supply in our dq variable. So we are going to append in this variable here into our dq list. We'll click enter. Now we'll reprint our dq list, and we can see that name Wicklow with the SQL of county equals Wicklow and isActive equals true has been added to the list. And we also notice that the map has not been updated. We will call the layer object updateDefinitionQueries function, and we'll supply in our definition query list. Hit enter, and we can see that the map is updated. If we right click on county boundaries and go into properties, we can see we have a newly added query where the name is Wicklow. It hasn't followed the usual convention where it's been query and an incremental number. We now have a name Wicklow where county equals Wicklow, and this is the active definition query. We'll click OK. Now let's create another definition query. This time we'll set this to be name will be test. The SQL needs to be something we haven't created already, so let's say county in, and we'll go with Dublin and Kildare, and we'll set the isActive to true. And we'll hit enter. We'll get our definition query list once more. So dq list equals layer dot list definition queries. We're then going to append our definition query to our list, and then we will update the layer objects definition queries, and we'll supply in our dq list. Now watch what happens when we hit enter. We get an error that there is more than one active query. If we right click on county boundaries and go to properties, we can see that our definition query has not been added. Using this method, we would have to make sure that there is no active definition query and then add one that is active. Click OK. But we can of course use the layer dot definition query property, and we can set this equal to our SQL. I'm just going to copy this county in Dublin and Kildare. I'll copy that and paste it in and hit enter, and this becomes the active definition query. If we right click in county boundaries and go to properties, we can see it has been added with an incremental query number 5. Click OK. In this video, we used the updateDefinitionQueries function to add a new definition query to our layer. We saw that this method failed when we tried to add a newly active definition query when there was already one active for the layer. In the next video, we will look at altering an existing definition query. In this video, we will take what we have learned so far and we will alter our existing definition queries. We are in our ArcPy definition queries APRX. Over on the left hand side, if we click into county boundaries and select properties, and in our definition query tab, we have 6 queries here, 5 that are named generically and 1 named Wicklow. We'll click OK. You might be here from the previous video, and if not, I'm going to clear this transcript. I'll right click on the input ribbon and select load code, and in our folders, ArcPy_DQ, click into Python scripts and select the alter definition queries _start.py script and select OK. Now I hope you remember that when we use the definition query property for a layer object and we supply in the SQL as a string, that it does not create a new definition query if that SQL already exists as a definition query. But what about for the workflow that we saw in the previous video, where we create a dictionary, we append it to our definition queries lists, and then we update our definition queries? Does this add a new definition query, or does it acknowledge that that definition query already exists? Well, we're going to find out here. We will click enter and run the code that we loaded, and enter again. Okay, we should be back up to where we left the last video. I'm going to right click in county boundaries and go to properties. And we can see that the Wicklow definition query has been added again. So this is something you need to be wary of. We're going to leave it there for now because in the next video, we are going to look at deleting a definition query. We'll click OK. This video is about altering existing definition queries. And we've seen this in the past when we updated all the isActive properties for our definition queries to false to turn off all definition queries for a layer. We'll mainly focus on updating the name property for our definition queries to give them a more semantic meaning. There's no point in leaving them as query 1, query 2, query 3. Let's get a list of the current definition queries for our county boundaries layer. We'll create a variable called dq_list and we'll set that to layer.list definition queries, and we will click enter. We will print the definition query list to screen. Let's update our query 1 name, and we can use list and dictionary conventions here. So we have our DQ list. We want to access the first element, which is our query 1. It is this dictionary here, and we want to access the name key, and we're going to set this to equal Mead. We'll hit enter. Now if we reprint our list, we can see that the name is Mead. Now we haven't updated the definition queries, so this has not been renamed in the layer. If we go into county boundaries with the properties, you can see it is still query 1. We'll click OK. But we can update this using the update definition queries function. So let's do that now. Layer.update definition queries, and we'll supply in our definition query list. Hit enter. Now if we right click on county boundaries and go to properties, we can see that our first query is named Mead. Click OK. Here's a little tip. Let's copy our list here. We'll copy and we'll overwrite our DQ list, and we'll set it equal to that list. Now we can simply go in here and change query 2 to Kildare. Query 3 we'll set as Dublin. Query 4 we'll set as Dublin and Wicklow. Query 5 we'll just change to Wicklow without all the caps. And for query 5 we will set to Dublin and Kildare. And for Wicklow, let's change this to delete. We'll click enter. Now we can simply run our update definition queries again. Hit enter. And if we go into our county boundaries and go into properties, we can see we have a fully renamed set of definition queries. Click OK. Now, maybe you're the type of person that wants your definition queries to be in alphabetical order. We can use the inbuilt Python sorted function to sort our definition queries by the name value. We'll overwrite our DQ list. And we'll set this equal to sorted. DQ list is the list we want to sort, and we will use a key equaling lambda, and we want to sort based on our definition query name key. This is the height of the slightly more advanced Python coding, I promise you. This will sort our definition query list in alphabetical order based on the name key. We'll click enter, and if we print DQ list, we can see that delete is first, and then we have Dublin, then we have Dublin and Kildare, and Dublin and Wicklow, and so on. And if we update our definition queries, and we click into our county boundaries properties, we can see that they are now listed in alphabetical order. In this video, we have seen how we can alter existing definition queries for a layer. We also saw that when we use the dictionary convention to add a new definition query, that ArcGIS Pro doesn't mind that that definition query already exists. And this is different from using the definition queries property, where it will not add a new definition query if that query already exists. In the next video, we are going to take a look at deleting a definition query for a layer. In this video, we will take a look at deleting a definition query from a layer. We are in the ArcPy definitionQueries APRX. No matter if you're following on from the previous video or just arriving here fresh, please clear the transcript, and we will right click down in the input ribbon and load code. Go into folders and into ArcPy DQ and into Python scripts, and please select the delete definition query _start.py script and click OK. This code will bring us right up to where we were in the previous video. If we hit enter twice and we right click into county boundaries and select properties, we can see our definition queries are in alphabetical order. Click OK. Although we have our definition query list here from the loaded code, let's use the list definition queries to get a fresh list. We'll set definition query list equals layer dot list definition queries, and we'll hit enter, and we'll print our definition query list to screen. We will delete our first definition query here where the name is delete. If we go into our county boundaries properties and into definition query, we are going to delete the first entry here. Click OK. Now, because the definition query list is a list object in Python, we can simply use delete definition query list and supply in the first index. Index 0 is relating to this definition query here in our list. If I click enter and then print the definition query list once more, we can see that delete has been removed. Now, it has not been removed from the layer. Just to make sure, we'll go back into our properties and we can see that it still exists. We'll click OK. We will need to use the layer update definition queries function, and we'll supply in our definition query list and hit enter. And now that delete named definition should be removed. Go back into our county boundaries and we can see it no longer exists. Instead of 7 queries, we now have 6 queries. Click OK. But what if we don't know the index for a named definition query? Let's use list comprehension to find the index for a definition query of interest. We'll set our definition query index variable to equal square brackets, and we'll start our list comprehension. will state for index definition query in enumerate the definition query list if our definition query name, need to add back in a square bracket, again, equals, let's go with Dublin and Wicklow. We only want returned the index, and because list comprehension always returns a list, we only want the first element of that list. We can see where name is Dublin Wicklow in our definition query list. This is the 1 to 3rd definition query, which means we should be returned an index of 2. Let's run our code and let's print out the DQ index. And we can see we did get 2. Now we can use the Python list method pop and supply in the index and click enter. We can see that that has been returned and that is also been removed from our list. It is now gone. It is still present in our county boundaries layer. We still have Dublin and Wicklow. Click OK. And we'll update that using the update definition query. If we go back into our county boundaries, it has been removed and we now have 5 queries left. Click OK. Let's use a little more list comprehension magic. We'll go back to our DQ index list comprehension. We'll change the name of the variable to just DQ. We're not interested in the index this time, so we'll remove the enumerate and the index. So what we want here is for definition query in our definition query list, if the definition query name is equal to Wicklow, return the definition query. And because list comprehension always returns a list, we want the first element of that list. And we should be returned this Wicklow SQL county equals Wicklow definition query. We'll run the code and let's print our definition query to screen. We can see it is our Wicklow definition query that we've been returned. If we type in our definition query list, we can now use the Python remove method and supply in our definition query. We'll hit enter and we'll print our definition query list to screen again. And this time the Wicklow definition query has been removed. It has not been removed from county boundaries layer. We can see that it still persists. If we click OK and we update our definition queries, and now we check our county boundaries properties, we can see we are down to 4 queries and that the Wicklow query has been deleted. In this video we showed how we can delete definition queries from a layer in ArcGIS Pro using ArcPy. We use the Python keyword del for delete to delete a definition query from our list of definition queries. And we also use 2 inbuilt Python list methods to delete definition queries. With each deletion, we had to update the definition queries by using the updateDefinitionQueries function for our layer object. In the next video, we are going to see how we can delete all definition queries from a layer. In this short video, we are going to see how we can delete all definition queries from a layer in one go. We are in our ArcPy definition query APRX. On the left hand side, if we click into our county boundaries by right clicking and go to properties, we can see we have 4 queries remaining. And we are going to delete all these at once. Click OK. If you are continuing on from the previous video, keep going. If you are coming back to this video as a reference, I will clear the transcript. And down the bottom, we will right click and load code. Go into the folders and into ArcPy DQ. Into Python scripts and select delete all definition query _ start.py and click OK. Click enter twice and this will bring us up to where we ended in the previous video. No messing around here, let's just delete all the definition queries, and we do that by simply using the layer updateDefinitionQueries function and supplying in none. In previous videos, we have been supplying in a definition query list, a Python list that contained dictionaries describing our definition queries. Whenever we altered a definition query, we used the updateDefinitionQueries supplied in our list, and it altered the definition queries in our layer. Here we are supplying none, and it will delete out all the definition queries. So click enter, and we can see that our map has changed back to the original data. If we right click and go into properties, we can see that we have no definition queries defined. In this video, we saw how we can delete all definition queries for a layer using ArcPy. All we had to do was supply in none as the parameter for the updateDefinitionQueries function. In this video, we will get a general overview through an initial look at Spatial Clause with a definition query that is available in ArcGIS Pro as a version 3.5. Here I'm in our ArcPy DQ APRX. This is a fresh download, so I do not have any definition queries on any of our layers. I am going to turn on the place names layer. I'm going to use a spatial clause with a definition query for the place names. I'm going to click on select, and I'm going to select County Wicklow. I'm now going to right click on place names and go to properties and new definition query. And where it says add clause, I'm going to do a drop down and select add spatial clause. From here, I have choose a layer or choose a custom extent. I'm going to use the county boundaries, and I'm going to use the selection. So we can see here it is the outline of Wicklow. I'm going to click OK. I'm going to click apply, and I'm going to click apply once more. Now if I click OK, we can see that the place names have been spatially filtered, or a spatial clause has been added to our definition query to only show the place names that intersect the Wicklow boundary. But let's take a look how that looks like in the back end of things. I'm going to go to analysis. I'm going to open up my Python window. Create a variable called APRX. Set that to equal arcpy.mp.arcgis project, and we will use the current string for our open APRX. We then want to grab a map, so we will create a variable called m for our map and set it to equal APRX.listMaps, and we're going to grab the first map. I print the name of the map, m.name. You can see we have our def query map. You can zoom in a bit here so you can see it a bit more clear. Now we want to grab place names layer. So I'll create a variable called layer, and we'll set that to equal our map object, and we're going to use the list layers function, and we'll put in place names, and of course we want the first layer returned from that list, and we can also print layer.name just to see we got the correct one, which we have. As we'll print the screen our layer object and access the list definition query function. Let's spell it right, list definition queries, and let's, oops, I'm not getting that right there at all. Let's remove one of those L's and rerun. So now we can see the makeup of that definition query. And most notably, we can see that this spatial clause has been added. Our name was set to query 1. We did not use any SQL clause. It is the active definition query. And now we have a spatial clause. This spatial clause is a list, and we can see it is a list of dictionaries. And within that dictionary, we have a geometry property that contains a geometry object. Now here it is a polygon geometry object. So if we want to include the spatial clause in our Python workflows, we are going to have to work with geometry objects. In the next video, we're going to see how we can use a single polygon. And then the following video after that, we're going to see how we can use multiple polygons to create that geometry object that defines the spatial clause. For now, I am going to clear my transcript here, and I'm going to go back into the definition queries. I'm just going to delete that and click OK, and we'll start afresh in the next video. I should also clear any selection that I have. In this video, we got an initial feel for the spatial clause with a definition query. Most importantly, we saw that the spatial clause uses a geometry object. Here we saw it used a polygon. In this video, we're going to repeat the previous lessons video where we saw an initial look at the spatial clause with definition query, but this time we're just going to do it all in Python. So we are going to access our place names layer and apply a selection to our county boundaries layer, where we need to extract the geometry from that county boundaries layer from the selection and then apply it as the spatial clause in our definition query. So let's go ahead and take a look. Here I am in the ArcPy definition query APRX, at the county boundaries turned on and the place names. In this workflow, we're going to access the APRX, access our place names layer and our county boundaries layer, place a selection on our county boundaries layer, grab the geometry from that selection, and then we're going to apply it to a spatial clause in the definition query for the place names. So let's get to it. We first want to access our APRX. So we use the ArcPy.mp.arcgis project, and we put in our current string to access this open APRX document. We'll create a variable called m for map, and we'll access the APRX and the list maps function, and we want the first map, which will be our def query map. We then want to access the place names layer, so we'll use the map object and the list layers function, and we want the wildcard to be the place names, and we want the first layer returned, just to see we have the correct layer, our current layer name, and we have place names. And we want to get our geometry layer, so we'll call it geom layer, and we'll set that to equal the map object dot list layers, and this time we are interested in the county boundaries. Because this layer returns a list, we'll access the first entry of that list, and we'll just check that we have the correct layer, and we do. We have our county boundaries. We now want to apply a selection on the county boundaries. We'll create a variable called self by selection, and we'll use the ArcPy.management select layer by attribute geoprocessing tool. We want to use our geometry layer, which is our county boundaries. We are going to place a new selection, and our where clause is going to be county equals, let's go with Kildare. We run that, and we can see that Kildare is now selected in the map. We want to grab the polygon geometry, or the geometry object, for Kildare. So we'll create a variable called geom, and we'll set that to equal a pair of square brackets. We are going to use list comprehension. We're going to use a search cursor. We have a whole course on search cursors. So for each row returned from an ArcPy.da.search cursor, where we're iterating over the selection. There is only one record in that selection. That's how we have to access it. And we are only interested in the shape at token, which will return the geometry object for a feature in a feature class. We need to close out square bracket there, and we're only interested in the first geometry returned. You can see I have a mistake there. That should be row. So let me just read this. So for each row returned in our ArcPy search cursor, on our selection, we want the shape token. If there were multiple in the selection, we would have multiple returned in the return list. And we're only accessing the first element returned. So if I click enter there and I can print geom to screen, we can see it is a polygon geometry object. Now we want to create our definition query, and we're going to use the dictionary style here. So we're going to give it a name, and we'll call that Kildare. I can spell Kildare place names. The SQL simply going to be an empty string. Is active. We will set to true. Of course, we want it to be active. And then we are going to use the spatial clause. And we'll set our spatial clause to be a list, because we saw it was a list in the previous video, and it was a list of dictionaries, and that dictionary had a geometry property, and that geometry property had a value of a geometry polygon object. So let's hit enter there. We'll create a variable called DQList, and we'll get the current layer definition query list, which is list definition queries. Print DQLists to screen. You can see it's an empty list, but we're going to append in our definition query into that. Now if I print DQ list, you can see our definition query in there. And then we're going to use the layer dot update definition queries call. If we keep an eye on our map there, you can see all the place names are currently shown. We have our Kildare selected, and we have our definition query ready to be applied. I'm going to hit enter. And the big reveal has been ruined because I forgot to put in the definition query list into the update definition queries. Now that I've run that, we can see that the place names has a spatial clause applied to the definition query, and we are only seeing place names that intersect our Kildare geometry. In this video, we saw that we could grab the geometry for a single polygon and use it for a spatial clause in a definition query. In the next video, we are going to select multiple polygons and see how we can grab the geometry from the multiple geometry selected and use it as a spatial clause in a definition query. In this video, we will select multiple county boundaries, meaning we'll have multiple polygons to factor into the spatial clause. We're going to use union to combine all the polygons that we have selected into one geometry object, one polygon object. So let's go take a look. We are following on from the previous video. Just to make things a bit neater, I am going to delete all of the current definition queries. There is only one, so I'm going to use the update definition queries call and supply in none as the parameter and click enter. And you can see we now have all our place names showing once more. I'm also going to clear the selection, and I might as well use ArcPy since that is the nature of these courses. And we use the select by attribute tool. I can grab county boundaries there, but I do know it is our geom layer variable. And this time we are going to clear selection on that, and we can see we have no selections on our map at this current time. Let's make another selection. We'll set that to equal ArcPy, and from the management toolbox we are going to use the select layer by attribute geoprocessing tool once more. We can still use our geom layer, which is our county boundaries, and once more it is a new selection, and we're going to use a where clause of county in, and we'll go with Wicklow, and let's use Dublin. enter. We can see those two counties have been selected. We will get a geometry list, so a list of geometries. There'll be two in that list, the two geometries for Wicklow and Dublin. Once more, we're going to use list comprehension. So for each row in the ArcPy.da.search cursor, and we want to iterate over our selection, and we are interested in the shape at token. We want row 0 returned. Row 0 here is just picking up the first entry in this list here, and we only have one, which is our shape, which is going to return a geometry, which will be our polygon geometry. So we will have two polygons in this geom list. If I hit enter there and then print that geom list to screen, you can see the two polygons in there. Now we want to merge those, union them into one geometry. So we'll first grab the first geometry. So we'll create a variable called geom poly, and we'll set that to equal our geom list and the first polygon in there. So it is going to be this polygon here. You might have more selected. So for each polygon, in our geom list, we will call our geom poly. So we have one polygon geometry already, and we'll set that to equal the geom poly dot union any other polygon that we have. Sorry, I've made a slight mistake here. We should have this going from the second in the list onwards, because we've already accounted for this polygon here. Just to recap, so for each polygon in our geom list, that's not our first geometry that we already grabbed, we're going to keep unioning. We'll go with unioning. It's kind of hard to say. Each polygon into the original polygon. So let's say we had 4 polygons in there. We'd already grabbed the first one. So on the first iteration, the second polygon is being unioned to the first. And then on the second iteration, the third polygon is being unioned into the geometry where we've already have the geometry from the first and the second, and so on. Anyway, let's continue. We'll run that. If I print geom poly to screen, you can see there's one single polygon. Now I want to create the definition query dictionary. So we'll have a name. Set that as Wicklow Dublin place names. We are not using an SQL clause, so we'll get that as an empty string. Is active? Yes, we want it to be active, so we set that to true. And then we have our spatial clause. And we know that's a list. That list contains a dictionary. That dictionary has a key of geometry and a value of the geometry, which is our geom poly. Enter. Now we want to get the current list of definition queries, so we'll create a variable called dq_list. Set that to equal our layer dot list definition queries. Print dq list screen. It should be empty. We don't have any in there, but we are going to call that empty dq list, and we will append in our definition query. Then call the layer and the update definition queries method, and we add in our dq list. Enter. And if we look above there, we can see that the place names have been filtered to Dublin and Wicklow only. So we've successfully applied a spatial clause where we used multiple geometries. In this video, we saw how we could select multiple polygons within a layer and then combine the polygon geometries from that selection into one polygon and use it for the spatial clause in a definition query.